2019, on the second part of the free response, part D, you put FW cosine of 60, but then you use like a.
Oh yeah, that was just a mistake.
So it wasn't supposed to be 17.
No, it should have been 20 or whatever.
Yeah,
the weight
okay.
was times the cosine of that 60.
Okay.
I don't. Okay.
Okay, I was wondering where you got 17 from, because we got 17 again early in the problem.
Right. I was just pulling. I saw that number and just wasn't, make a mistake sometimes. I know. I understand. All right. Well, you want to look at the free response? Just start with that. I'll show you what the free response is going to be like. So, well, let's do this number 2 right here. This is the fall 21. This is your free response regarding the inclined plane, and yours is going to be a lot like this. I don't remember if it had a force going up like that, but it's going to have a frictional force and asking what the frictional force is, and then also assuming no friction and asking what the acceleration is. There are only 3 questions on your exam for this, 3 sub-questions for this. So your first step is to draw your coordinate system. We'll always draw it with the x-axis perpendicular to the plane, and then label our forces. There's our first force, that's at F equal 120, and then we'll always have a weight that's acting down. I like to go ahead and label my force, my angle there. I know that's 90 minus 30 or 60 degrees. And then I also have a frictional force that's going down the inclined plane. The reason it's going down the inclined plane is because F is pulling it up the inclined plane. And then I have the normal force as well, so Fn. I'm going to go ahead and resolve these forces on this. So I'm going to resolve Fw into 2 forces. That's going to be Fw sine of 60 and Fw cosine of 60. So now that I resolved it, I'm just going to erase this. So there I combine my steps where I label all my vectors, and then I combine that resolving vector step. So that's my final coordinate system. I know that it's at an angle, but if you can just sort of do your head like this, then you'll see it rotated back, which you usually see it. Okay? Or you can redraw that, that's fine. But to find the normal force for part A, probably going to have to do something like this. I mean, you will have to find the normal force, but it may or may not be a question. But to find the normal force, because the normal force is on the y-axis, I say the sum of the forces in the y direction is 0. For the inclined plane, it's always 0, right, because it doesn't move off of the surface. That's one of the advantages of having that rotated coordinate system. So the sum of the forces in the y direction is 0. That's going to be Fn minus Fw sine 60. Equals 0. So Fn equals Fw, which is 100 sine of 60. That's 87. Okay, so that's the first part. The normal force is 87 newtons. And then if there's no friction, what is the acceleration of the block? Well, here, what I consider the y or the x. It's accelerating along which axis? The x-axis, right. So I say the sum of the forces in the x direction, that's equal to max. And then I look at my coordinate system up here. I have this in the positive x direction. That's 120 minus Fw cosine 60. That's equal to max. I left off the frictional force because I'm assuming no friction. You could put it in there, but it'd just be equal to 0. So here I get 120 minus 50. That's 100 cosine 60. Is equal to the mass, which was 10, times ax, and then so ax is 70 over 10 is 7 meters per second squared. Okay? And then for part C, I want to know what is the frictional force on the block. Well, C is just going to be Fk equals mu k times the normal force. So that will be 0.1 times what I found already, which is 87, or 8.7 newtons. Now, if you get the 87 wrong for the normal force, but you do this part right, then I'll give you full credit for that. You won't get full credit for part A, for example, if you get that part wrong, but if it carries down, then you will get full credit for part C if you do that part right. And then finally, part D, I want to know the acceleration. So I do part B all over again, except here I have a non-zero frictional force. So that's 120 minus FW cosine 60 was 50 minus 8.7, that's my frictional force, equals MAX. Okay? And then AX is whatever it is. I think we did this problem in class, but your free response is going to look very, very similar to this. Okay? Y'all could do that today if I just gave you this problem without much difficulty.
So you got that, for C, you got the 8.7 from doing FK over FN?
No, the 8.7 is the frictional force. And remember, for our frictional forces, F is equal to mu times the normal force. So mu is given. Mu is the coefficient of kinetic friction.
Mu is given.
Yeah, mu is given. I know in some problems it's not, and you have to do the ratio. But here it is given.
So you just did 0.1 times FN.
Yeah, Fn was 87, so I did 0.1 times that value. Okay? So yeah, you will definitely have to use this equation for that free response because there will be friction on part of that problem. So you have to use that or some variation of it. Like I might ask you to find mu or something like that. Okay?
So mu is the coefficient?
Yeah, mu is the coefficient. And I know it looks like an M, the way that well, that's not the way I draw it, that's the way the mu looks. But it's really like it's a U with a little tail on it. And mu is the coefficient. Yeah.
For the vector for response, what did you say it would be staged as?
What would it be staged as?
Like, I think you said something about it in class.
Yeah, it's going to be two vectors. You know, vector A is 5 units at 30 degrees, for example, from the x-axis. I don't remember if one of them was on axis. I don't think it was. And B is 4 units at 30 degrees, or no, let's do 60 degrees above the negative x, and I ask you to find the sum of those. Something like that. Y'all want to do this one?
That's like AX, AY.
Yeah. Yeah, the first step you do is you find AX and AY, and then you find BX and BY. I find that it's always useful to draw those vectors. So A is right here, vector B is right here. And in fact, if I was to draw vector B tail to tip, it would be something like that. So the resultant vector would be something like that. It's going to be close to 90 degrees for this one. I don't know if I drew it very close, but you get the rough idea. So if you sort of sketch it out, you'll see roughly where the resultant vector is supposed to be. So this is going to be 5 cosine 30, which is 4.3. This is going to be 5 sine 30, which is 2.5. All right, so I did a 5 cosine 30 here. I did 5 sine of 30 here to find the x and y components. And here I do 4 cosine 60, that's equal to 2. And then 4 sine 60, that's equal to 3.5. So I find those x and y components, but I need to be careful about the signs of the x and y components. This is positive, this is positive. Bx, however, is negative. Notice its x component is in the negative x direction. And you'll probably have a vector that's in either quadrants 2, 3, or 4, so that one or both of the components are going to be equal to a negative number. Then I add my ax and bx and my ay and by. That's going to be, in this case, 2.3. And here, what's that, 6. So I add those up, and this gives me the x component of the resultant vector and the y component of the resultant vector. Then if I want to find the magnitude and direction, I do the square root of 2.3 squared plus 6 squared. That is whatever it is. And then to find the angle, I'll call it phi in this case, it's the inverse tan of the y component, that's 6 divided by 2.3. and that's equal to 69 degrees. I must not have drawn my thing very well. Did I not draw it very well? Is that right? Y'all see any errors that I made there? I think I did it right. Yeah.
If it would have said 4 units at 60 degrees, like from positive or above, if it would have been like a negative y, would the 3.5 be negative?
Can you repeat that? If
Like
it would have
if
been.
it said like 4 units at 60 degrees and the negative y-axis, that would be by would be negative instead of like below negative.
I'm never going to measure the angle from a y-axis. That's just, I don't do that. I might measure it from the negative x-axis, and in fact, I probably will. I'll probably give you in one of those quadrants 2 or 3, so that you have to deal with those negative x or y components. Does that answer your question?
I think so.
Okay.
So if it was below the negative x, then the bx and by would be negative?
Yeah, so if the vector b was down here instead, yeah, bx and by would both be negative. And if it's in quadrant 4, then bx is positive and by is negative. That's why knowing your unit circle is really useful. Okay? 69 degrees doesn't look right for that, but I think I did it right. I think I just didn't draw it correctly. Sorry, I got less than 8 hours of sleep last night, so I'm just sort of running on fumes. Did you just smirk at me? Huh? Sorry. Okay? All right. What do y'all want to look at? Projectile motion? You want to do a projectile motion for the free response? We've done those before, but I mean, it's been a while. Or do you want to look at some particular multiple choice? You will have 2D problems in the multiple choice as well, so don't disregard those. Can we do this one, number 25, since nobody's speaking up? This is, I'll tell you why I want to do it. This is fall 18, number 25. This is fall 18. It's a 2D problem that we haven't done very many times. I think we've just done it maybe once, where I have this guy that's pulling up on the block. We did one where we were pushing down on an object, and then we had to figure out what is the normal force. So in this case, I'm not saying this is on the exam, but you will have some 2D problems or situations where the normal force is not equal to the weight. And that's what we have here. Often, if I have an object, then the weight of that object is equal to the normal force. But notice here I have another force, this 40 Newton force, at this angle of 30 degrees. So that it's the normal force will now be, well, will it be less than or more than the weight? I'm pulling up a little bit on this object, so is that going to increase or decrease the normal force? It's going to decrease it, right? So, did you say decrease?
Wait, it's decreasing?
Yeah. So imagine, like, if you're standing on a scale, like on a body scale to measure your weight, if I pull down like this, it's going to make the scale read more, right? The scale actually reads normal force. It doesn't read your weight. That it's actually measuring the force that's pushing upward. But if I push down like this, if I'm standing on the scale, what's going to happen to my weight? I mean, what if I do this? What's my weight? If I lift myself all the way up? It's 0, right? So if I'm pulling up, if I'm pulling up, if I'm applying an upward force, then it's going to cause my normal force to decrease. We'll see that here. Let's find this normal force. Same steps as we've had before, okay? I'm going to resolve those vectors. I have my normal force, Fn, and my weight, Fw, and then I have this 40 cosine 30, and then I have 40 sine 30. And if I want to know the normal force, I'm going to look at the forces in the y direction. Because it's not moving in the y direction, it's on this surface, that's equal to 0. And so I have 40 sine 30 plus Fn minus Fw is equal to 0. And if I want to solve for Fn, it's going to equal to Fw minus 40 sine 30. And what was FW? 110 minus 20, that's equal to 90 newtons. So 90 is the right answer. But notice that there were other options there that you might have fell for. If you thought that the weight was equal to the normal force, you might have put that answer. Or if you got your signs wrong, if I had, say, a negative right here, I would have gotten 130. The other two are probably not as likely to answer. But those are sort of misleading answers A and B. As I've told you before, just a second, Luke. So as I've told you before, I do know sort of the common mistakes that people make, and I'll put those in as answers. So just be careful. Even though you get an answer, it doesn't mean it's the right answer. So, work expeditiously. You only have 60 minutes to complete the exam, but make sure that you're going carefully too. Luke?
So when you're adding the force of the lifting upwards to it, you just put it in the y-axis and you don't do it to the side.
Oh, well, yeah, so it does still have an x component. That's right here. Is that what you're asking about?
Oh, yeah, okay. I was seeing that as being the y direction. I was confused for a second.
Yeah, I think this test actually had multiple questions regarding this. Oh, no, it didn't. But in the past, I've had similar questions like this where I ask other things. Like I'll ask first a multiple choice, what is the normal force? And then I'll ask, well, what is the frictional force? And then what is the acceleration of the block? So if there was a frictional force on this block, it would be going in this direction. And I could have found it now. It would be mu times the normal force. Now that I have the normal force, I can find that frictional force. And then if I want to find the acceleration, then I do the sum of the forces in the x direction, which would be 40 cosine 30 minus fk, whatever it is, if there was a frictional force in this, is equal to max. Then that's how I'd find how quickly that block is now accelerating. Okay? All right. What else? Yeah, did I see it? Yeah. So we did one in class like this. Remember this one, there's a similar one in your homework where the angles are different. I'm not going to give you a situation where the angles are different. Okay? And if you recall, in the homework, the one we did in class, because these angles are the same, we found that the tension in this side was equal to the tension in this side. All right, let's take a look at this. So I'm going to draw my coordinate system. I've already labeled two of those forces. That I'll call this FT. Well, I called it FTL and FTR when we did it in class. And then I also have the force weight. That force weight is equal to 220 newtons. 22 times G is 220. And I want to know what is the tension on the left side. So see, I first want to label my angles. These are both 60-degree angles. And now I can resolve those vectors, and I should begin to see a solution sort of pop out. I'm going to have FTL, FTR, sine of 60, both of these. And then over here I have FTR cosine of 60, FTL cosine of 60, and then I have that 220 Newton vector going downward. So a couple things to note. These two vectors are equal and opposite because it's a static situation. The sum of the forces in the x direction is equal to 0, so those two have to be equal. That means that FTL is equal to FTR. That only happens when the angle is equal, okay? So FTL is equal to FTR. That means that I can combine these two and just say that these are equal to 2FT times sine of 60. Right, if FTL is equal to FTR, then I can just replace that with a twice that value. And then I do the sum of the forces in the y direction. That's 2FT sine of 60 minus 220 equals to 0. And I solve that for FT. So that's going to be 220 at 110 divided by sine 60. I get 130 newtons. So FT equals 130 newtons. Okay. So same procedure that we did where we label all of our forces, we resolve our forces into the x and y components, and then we apply Newton's second law. But on this problem in particular, we needed to recognize that those two tensions were the same. Not going to give you one with different angles. Y'all come on in, guys, if you want. It's okay. Y'all coming in, or are you just lurking outside the door? Alex, hi. Are they coming in? Bye, Amy. Are y'all coming in, guys?
No, we were, but we might be in a different room. I don't know. It's just our room. We're going downstairs at 10:30.
Oh, for Dr. Doe? He told me I could use this room.
We're going downstairs.
Okay. All right. How are we doing? Okay. What else? Other particular problems? You are going to have one of these questions where I ask you to find the right equations. Do y'all know how to do that? You want to do this one? You definitely, let me find a different version. No, we'll just do this one. So this was a multi-part problem. This was before I gave free response. So there were multiple parts, but they were multiple choice. So you're welcome, by the way, because the free response makes it a lot better for you, because then you can get one wrong in the first part, and it doesn't trickle down into your other questions. You're welcome. You're welcome. Thank you. I appreciate that. All right. There you go. All right. So let's just draw my coordinate system right here. Hey, Yushin. It's okay? All right. Thank you. All right. Go ahead and draw all of my angles or my vectors. So this is my normal force. My weight was down, but I'm going to go ahead and resolve it into my FW cosine of what's going to go there. What angle? Huh? 60 is the incline angle, so it's going to be 30. Right. Remember, I always do 90 minus the incline angle. And then this is FW sine of 30. And it says it's frictionless, although I'm assuming that it does experience a force due to friction. It's moving down the inclined plane, it says right here. So that means that the frictional force is in that direction. So that's my resolved vectors. So let's look at each one of these. FW cosine 30 minus FK is equal to 0. What's wrong with that equation? There is something wrong with it. Can you see? Yeah, Lucas? That's right, yeah. So this first part is correct, but this should be equal to MAX, that it's not equal to 0. Fn minus Fw sine 30. Oh, that's right, Fn minus Fw sine 30, but what's the problem? It doesn't equal MAX. I can make that right either by making this a y or just setting it equal to 0. Either one of those would be correct. And then Fn plus Fw sine 60, that's just all wrong. Yeah, so that's the Fn. To make it right, I would say Fn minus Fw sine of 30 to make that right. So it looks like, oh, none of these are correct. C is the right answer. So you'll definitely have a question like that where you have an inclined plane and you have to answer which of these equations are correct or not correct. All right? You want to do a projectile motion? We haven't done that. Want to do that just to, jog your memory? Look, this is fall 17. Again, this is like your free response, but it's in multiple parts, and I did it as a multiple choice on this fall 17 exam. So you're going to have a question where the object starts, goes up, and comes back again, like that, and you have to tell me some variation of what is the vertical range, what is the horizontal range, something like that. But always it will begin with finding the time, and you find the time by saying Vy at the top is equal to V naught y plus AYT. I like to go ahead and just find my V naught x and V naught y. I recommend that you do that. You're just going to need it. V naught x is going to be 40 cosine of 30. That's 35. And then V naught y is 40 sine of 30. That's 20 meters per second. All right, so just go ahead and find that as soon as you sit down with a problem, because you're going to need both of those. So here I have Vy at the top is 0. That's 20 minus 10 times t. This is t top. And so t top is equal to 2 seconds. Oh, that's what the question was asking. What is the time to reach its maximum height? What is the total time that this object is in the air? 4, right. So I just double that. If this is 2 seconds over here, then this is 4 seconds over here. You need to go, Bryce? No, okay. All right, so that's my t total is 4 seconds. And then so if I want to know the range, I would say x is equal to v naught x times t, or I could just say vx is usually how we write that, because remember, vx doesn't change, that it's always the same. So I have v naught x, which was 35 meters per second, times 4 seconds, that's 140 meters. That's the horizontal range. And then what is the x component of the velocity? Well, I've already found that, right? It's 35 meters per second. And your free response will be similar. Like there'll be some things that, like the x component of the velocity. Oh, I found that already. And so you just write down the answer. Also, be aware that I might ask you to find the velocity at a particular point. Say this point right here, let's say that this is 3 seconds. And I ask you, what is the speed of the ball at 3 seconds? There are 2 things that you would need to do. First, you would say, I'll do it right here. First, you would say that Vx at 3 seconds is equal to 35 meters per second. That's just the initial velocity. That's what we found up here. And then you would say Vy at 3 seconds is equal to 20, that's V naught y, plus negative 10 times 3, that's the time at 3 seconds. So 20 minus 30, that's negative 10. So now I have 2 components of that velocity vector, and to find the magnitude of the speed, I would say the square root of 35 squared plus negative 10 squared, but I'll just leave off that negative when I do that squared. So that'll give you the answer for the speed. I'm pretty sure that I asked that question. It's been a few days since I worked through that problem, but I'm pretty sure somewhere in the exam I do ask you to find the magnitude of the speed at a particular time. Don't forget, too, that there are those other 2 types of projectile motion problems. That's the horizontal launch and then the launch that's at an angle. If it's at an angle, I'll give you some additional information to make that problem easier. Usually I give you the time. And so in that case, it's really just a matter of plugging in for the time. Okay? All right, what other questions you'll have? So you don't disregard the conceptual questions. Often that's the ones that people miss. You'll have graphs like this. There'll be questions like this about just which of these statements are true for projectile motion. Just review your notes about, the qualities or properties of projectile motion throughout the trajectory.
It looks like if you shoot an arrow at 30 degrees, with like a velocity of like 100 meters per second, how far does it go?
Mm-hmm.
You do that.
Well, that's the one that we just did, though. Yeah, so that is exactly the same as this, where it's exactly the same, where you find the initial x and y components of the velocity, you find the time at the top, and then you find the total time, and then to find the range is that way.
Oh,
You understand?
yeah.
It is the same
I was
problem.
saying, I don't know why I thought they did something.
Y'all look like you got less than 8 hours of sleep last night. Is that true?
Yes.
Yeah, y'all try to get rest tonight. Like, probably the best thing that you can do tonight is rest. Harper?
I had a question about number 4 on the fall 20 exam.
Yeah.
You it gave us y, but then you kept y positive, and I don't know, you did something weird.
Where are you from?
Where am I from? Mississippi.
Ah! I thought I
I've
liked
gotten
you.
that a lot.
Huh?
I've gotten that a lot.
I'm from Mississippi, too.
Where are you from, Mississippi?
Near Meridian, Quitman.
I guess I'm from Hattiesburg.
Oh, yeah, okay, yeah. I'm sorry, what was your question?
So you gave us the y, which would be usually it'd be negative 100 because it's 100 off the ground, but for some reason you kept it positive, and then you used the y equals v naught yt plus half of ayt squared. but you didn't use you didn't put negative 100 equals all that.
Oh, yeah, because, yeah, good question. So, when I have something like this, and I want to know the y position at t equal 5.4 seconds, if you encounter one of these, this is probably what it's going to look like. I'm going to give you this time. And you're saying, well, I just did y is equal to v naught y times t plus 1/2 ay t squared, but that I didn't put in y equals to negative 100, right? Is that what you're saying?
Yeah, you solved for y.
I solved for y.
And then you, I think you did 100 minus whatever you got for y. And that was
Yeah, okay, because the first thing I want to do is I just want to know at t equal 5.4 seconds, let's say that's like right here, that I want to find out what is the y position at that time. And because this is a parametric equation, this y equal v naught yt plus 1/2 ayt squared, that it describes the y position as a function of time, I can find the y position at any time. If I know the time, I just plug in the time and I get that y position. So when I put in 5.4 for t, then that tells me what is the position. I don't know what v naught y is. Oh, it's 12.5. I'll just say 13. So if I put in that that time, then that tells me the position at that particular time. You're getting mixed up with the other problems where I have to use the y motion, the y displacement to find the time. But here I have I have the time, so I don't need to use that y displacement. You're thinking about, say, in this problem.
Is that because, like, on the problem you're drawing right now, it's going all the way down, and it's not like at a certain point going down? Like on number 4, it's at 5.4, which isn't the
Yeah.
total t. It's not all the way down.
Right. I'm not asking for the total time. If I was looking for the total time, you're right. I would say, what is the time at this point? And then I would say, well, I know that y is equal to negative 100 at that point. So I'd put in the negative 100, and I would solve that for t. We did that in lab, right? But I'm not going to make you do that because you have to use the quadratic, and you got all those a's, b's, and c's floating around, and everybody messes that up the first time. I do too. It's hard to keep track of all those a's, b's, and c's in the time that we have.
But once you solve for y, you keep the 100 positive, and then you do 100 minus whatever you get for y.
Now, the 100, okay, so let's see. The 100 is not irrelevant.
You don't use it at all.
Well, I think we do use it in a different way. So this works out to be minus 75 or minus 76 meters. So that means that this is at minus 70, or I guess it was minus 78 meters. Is it D the right answer for this one? Do you know?
I think it was, I'd have to go back and find.
Yeah, so I get minus 78. That means that this is y equals to 0, and it drops 78 meters in those 5.4 seconds. But look, I'm asking for the options are all different. Some of them are above the edge of the cliff, above ground level, below the edge of the cliff, above ground level. And so if I'm 78 meters below the edge of the cliff, that means that this distance is 100 minus 78, or 22 meters above ground level. So D is the right answer. That's where that 100 comes into play, is just finding the difference between where it is to measure it from the ground level up instead of from the cliff level down. Like in the lab when y'all did the shooting through the little ring, that you measured the amount that it dropped, but then you subtracted from the total height to find how far the ring goes up. I'm not sure if y'all did it that way in lab, but that's the easier way to do it. Okay, you understand?
Mm-hmm.
But almost certainly you're going to have to just plug in the time and find the velocity or the position at that time, for if it's a type of problem like this. Okay? All right. Other questions, John?
Questions that you were like, interesting from the exam. So you were talking about I think you were talking about the monkey and the rifle, and how we won't put those on the exam. Like, which ones should we focus
I think I was talking about the quiz when I said that.
Oh,
Yeah, I was talking about the quiz when I said that. So no, everything's fair game. But I don't know. The concept tests are useful to review. Like I said, you will see some where you have. I'm pretty sure that I had some graphs like this and analyzing the x position, y position, x velocity or y velocity. Things about like projectile motion, just where there's statements, and I ask you, are they true or not? Pretty sure there's that on there. Same for the inclined plane, just are these statements true or not? About hang time, can all of them? Is that an appropriate answer? All of them? Okay, yeah, all of them. Okay. But if there are particular ones, we can review them if you want. If there are particular questions, we can look at them. You don't look like you want to go. Do you want to go? Okay. We can stop. I'll hang around. If you have questions, I'll be here.